Good morning. Welcome to the video lecture for the subject Introduction to Artificial Intelligence. I am Dr.M.Hemalatha from RMDEC CSE department. Let us look into the classification types of ML algorithms. Machine learning algorithms can be broadly classified into three, namely supervised learning, unsupervised learning, reinforcement learning. The learning depends on the type of data. Is it going to be a continuous data or is it going to be a categorical data? If my variables are continuous variables, under supervised learning, we have regression, decision tree, random forest algorithms. If our data is going to be categorical data, then under supervised machine learning comes the classification. If my data is a continuous data, if unsupervised learning, then it is called as clustering. And for a categorical data, under unsupervised learning, it is an association analysis or a HMM, hidden Markovian model. Let us look into the supervised machine learning algorithm in detail. Here the algorithm is trained on labeled data. Labeled data means for each input, technically for each feature, the corresponding output, the label or target is provided. The goal of supervised learning is to learn the mapping from the input to the output, from feature to the label, and make accurate predictions for a new unseen data. A new unseen data which is provided to the ML model is called as test data in ML terms. So how is this learning process happening, or what is learning process? We are provided with input features. Under supervised, input feature will be provided, output label will also be provided. So learning is supposed to happen. So what is this learning going to do? This is going to find out relationships. How? Between input and output. How? By adjusting the model's parameters and the prediction value and the actual value. There might be difference. But with repeated thing, the difference between the prediction and the actual labels should be minimized. And this process is called as the learning process. So the work process of supervised learning is first training, followed by the learning process, followed by the model evaluation, followed by the performance optimization. Under supervised, the second type is regression. It is also a supervised learning technique. Here for a continuous numerical value. We are predicting a continuous numerical value based on one or more independent features. What do you mean by independent features? Simply inputs. It finds relationships between the variables to perform predictions. It finds relationships between the features and the target. Features are also called as independent variables. Target is otherwise called as dependent variables. We have to find a prediction between the relationship between the independent and the dependent variables. There are different types of regressions like linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression, ridge regression, lasso regression. We will look into very few of it. First type, linear regression. Second, polynomial regression. Linear regression in turn could be a simple linear regression or a multiple linear regression. So what is the meaning of linear regression? It is a supervised learning. So two things will be given. Features, input will be given. Labels, target will also be given. A good example for simple linear regression would be salary of an employee based on his experience. So years of experience is a feature denoted as X and salary is the target denoted as Y. Simple linear regression is used for predicting a continuous dependent variable. It assumes a linear relationship between the features and the target. Here, we have to predict an employee's salary based on the years of experience. If we want to represent this machine learning model in a mathematical way, then this is the equation, a linear equation, where my B stands for bias, Y is my target, X is my input, the feature. The second type of linear regression is multiple linear regression. This is an extended version of linear regression where multiple factors will be impacting my target. Say suppose we want to predict the price of a house. It's so many features like the footage, how much of a squared footage, how many number of bedrooms, where is the locality, in which locality is the house put up. All these features decides the house price. So multiple factors will be impacting the target. For polynomial regression, here we'll try to model a non-linear relationship between the features and target. Here there will be a linear relationship between the feature and the target. Here we can't expect a linear. Sometimes, majority of the time, they will be non-linear. So polynomial regression is a model which is for identifying relationships, non-linear relationships between the feature and the target. It follows an exponential trend or a quadratic trend, and here it follows a straight line. Here it follows an exponential or quadratic rather than a straight line. So the mathematical representation could be y is equal to w0 plus w1x plus w2x square plus w3x cube till wnxn. So example could be predicting the population growth over time. Let us look into the simple implementation of linear regression through a Python program. So what are the steps required for it? First step, import the required libraries. Second, my training data. This is a supervised learning, so I have to give both the label and the feature. Then we are training the model. Next, we are supposed to predict a test data. What will be the value for a test data, and try to plot the graph. So the libraries required would be NumPy, matplotlib.pyplot, and sklearn linear model. X is my experience. It's an array of 5 entries. Salary is my label, and this is my label. We are training the model, for which I call the linear regression method, and then we fit the model. For a new data, if I have 6 years experience, what will be the salary? So my model will predict and let me know what is the salary. And then this is our plotting the line. So when we plot this line, we will be getting our output like this. We get a straight line because this is a linear regression. Again, the next type, as quick recap, ML algorithms could be of supervised or unsupervised. Under supervised, regression and classification. Under classification, we have 3 further classifications, 3 different types: binary classification, multi-class classification, multi-label classification. Under unsupervised, we have clustering and dimensionality reduction. So what is classification? It is a type of supervised machine learning algorithm. It is used for predicting discrete outcomes. It could be true or false, yes or no. So there are Classifications could be of two types, binary or multi-class. Binary classification means my outcome can take up only two possible values. If it is multi-class, then it can take up more than two possible values. Examples could be logistic regression and decision tree classifier. So, logistic regression is a statistical method for binary classification. This predicts the probability of an event occurring. The event could be something like yes or no, spam or not, diseased or not diseased, cancer or no cancer. So, it models the output using some logistic function. An example could be a sigmoid function. So logistic regression could be further of three types: binary logistic regression, multinomial logistic regression, ordinal logistic regression. Binary logistic regression, the target variables have only two possible outcomes. So, multinomial means they will have three or more nominal categories. If it is ordinal, they will have three or more ordinal categories. Now, we should remember the types of data which we have seen in the previous lecture. So, you have a nominal category, ordinal category of data. Thank you.